Perfection. What is perfection? Why is perfection? Is perfection really possible? The word imperfection literally spells I'm perfect. For thousands of years, our best and brightest minds have debated what perfection truly is. I am not one of these minds, and I personally am tired of perfection. In the software engineering world, you must have perfect code, perfect syntax, perfect indentation. To me, readability is really just you admitting that you aren't a high-level programmer. Think about it. If you can read your code, who else can? That unpaid intern in the corner is itching to take your job. And if ChatGPT can do what you do, your future's looking pretty shaky there, buddy. The solution? Create code that is so unreadable, your bosses will be forced to keep you employed to maintain the dumpster fire that you've made. Today, I revolutionize the way I program by aiming to code the least readable, most inefficient code to ever grace the earth. Using a technique that I am pretty sure nobody has ever used before, I will create code that only I can read. Before I begin, I'm going to need to Mr. Beastify this challenge for myself. This is YouTube, and if you want views, you need to include a challenge. That's why I went out of my way to buy a $25 Arby's gift card, luxurious I know, and challenge my friend Akash to code the worst code.
All right, let's call Akash.
Hello.
Akash, can you turn on your camera?
Yeah. Yeah. What's up?
Yeah. All right.
What? What happened?
I have a Can you move your camera down a little bit? Like a little bit more. All right, that's tough. That's tough. I have a proposition for you, Akash.
Okay, what's the proposition?
Do you like Arby's?
Yes, I love Arby's.
Okay, that's kind of weird, but I guess.
What's wrong with Arby's?
I got a $25 Arby's gift card on the way.
No way, bro. Bro, can I have it, please?
If
Please.
you do one thing.
What do I gotta do, bro? Oh, please.
You got.
Please?
It's a challenge.
What's the challenge?
All right, bro. Yo, you could cut the act, bro. The challenge, bro.
Arby's,
You gotta code the worst code possible.
The worst? Or why?
I challenge you today for $25 to Arby's to code the worst calculator possible.
I'm in.
All right, so 3 days. You have to code a working calculator, but anything that's going on behind the scenes is totally up to you. If you want to make it like recurred 100 times, like that's what I'm calling recursion, recurred. If you want to make it recurred 100 times, right now it is Wednesday, so on Saturday. Wait, yeah, Saturday.
I think that's okay. I don't think that's 3 days. Can we have the viewers decide who wins?
No. Are you ready?
Okay. Yeah.
All right.
Yeah.
I need you to say I'm ready.
I'm ready.
Okay, bro, that's tough. That's tough.
As you can see, he was ready. So you may be wondering, God level coder, expert hackerman, flingbore. Hey, you said it, not me. How do you plan to create such bad code? I'm glad you asked. And I'll answer your question just this once. I plan to implement a coding architecture nobody has ever used before. I'm calling it cloud-hosted recursion. I first came up with the idea for cloud-hosted recursion when I was dreaming. In this dream, the three words that every programmer fears the most started to beat me ruthlessly, and that's when I knew that this was a perfect idea. Let's analyze this approach word by word. First, cloud. Code that is stored locally is way too easy to debug. If I can see the code, I can easily fix whatever problems it has. This is great if you're a low-level programmer who needs their code to be readable, but for us, it's unhelpful. I want all of our code to be in the cloud, a magical realm where we can pull down the snippets rather than host them locally. Next, hosted. I'm going to store our code on an SQL server. That means to access the code we need for our program, we need to make separate SQL requests for every segment. Say you want segment 1 of the calculator. You make that request to our server for ID 1. After waiting for a latent response, you can now execute the first bit of your code. Lastly, and by far my favorite, is the recursion aspect. If you do any programming, you probably hate the word recursion. And if you don't, you're probably a lot better of a coder than I am. Just having our code hosted is already something that should never see the light of VS Code, but I want to take it a step further. The bits of code we pull from the server will call the server themselves. This creates an architecture like this. The user starts the calculator. Code segment 1 is pulled from the server and executed. Inside of code segment 1 is a request to pull code segment 2 and execute that. Code segment 2 contains a request to pull code segment 3, and so on. This creates the worst diagram ever produced by man, and hopefully the worst code. Now that we have the idea laid out, how am I going to create this monstrosity? I wanted to use one of the most readable coding languages, Python. Python is a high-level programming language, meaning there's a lot of abstraction between it and the machine code. Reading Python is almost like reading plain text English, meaning that it is easy to debug and easy to begin with. This is obviously bad. As programmers, we must ensure that nobody can find joy in coding, which makes Python an obvious choice as a target for me to ruin. First, we code a simple calculator that we will Frankenstein into the bad code we need. Done. This calculator is so simple that your grandma could probably code it, if she knew Python. It takes a user input for the first number, the operator and the second number, then outputs the result. Super easy, super readable, way too good. Time to spice things up. To implement SQL recursion, I will create a PostgreSQL, PostgreSQL, yeah, the word on screen, database. Think of this as a locally hosted table that will host our code. Personally, I love typing SQL. It gives me an outlet to yell at the computer. In other languages, you have to type in this respectful manner, using nice punctuation and lowercase operators. SQL has everything in uppercase. To select a table, you don't just say select, you select from table. Truly intuitive. We first create a database using create database. Then we create a table using create table. Then, using the command insert into table ID code values, we can insert chunks of code into a table. Back on the Python end of the program, we use scopg2, we use scicop point guard, sidecop, the word on screen, to make a request to our local server. A hop, skip, and a jump later, and it's alive! We can now access our SQL server and get results. Now to execute. The worst function in Python by far has to be the exec command. There is almost zero reason this command should ever be used. Unless you're building an IDE or some other scripting-based program in Python for some reason, you should never use exec, unless you're in a weird manufactured coding competition with your friend. What exec does is simple. It takes a string and runs it as Python code. To do this, it compiles the string into bytecode, which is the low-level machine language that your computer speaks, and then runs it in the global namespace. That means that whatever is in an exec statement is run everywhere and nowhere all at once. Legitimately the worst thing possible. This quirk of exec means a couple things. One is that when using the exec statements, nothing is debuggable. Anything inside an exec statement will simply point back to the statement it was created from. And instead of giving the line that failed, it simply just points back instead. This legitimately makes any attempt at cleaning code nearly impossible. Another quirk is that our exec code won't have any access to variables we define elsewhere, and each exec will be almost like its own individual process. If we place a piece of Python code in our server, e.g. print hello world, retrieve the data using our Python, and then wrap the result in an exec statement, whatever we put will be executed. This is bad. Really, really insanely, terribly bad. Let's code it. We now have a method to execute code that won't even be hosted on our system. Nice? Now to begin coding our cloud code. Say that 5 times fast. Coding cloud code, coding cloud. To migrate our pre-existing calculator, we must first build a template for our connection. I want each code to seek its own connection to the server, maximizing resource inefficiency. That means that before completing, our code will have established up to 4 active connections to the SQL server between its different execs. Look at this piece of code. Notice anything? If not, you're probably not an SQL engineer. Don't worry, neither am I. See that bracketed variable? Allowing the user to control that variable inputted directly into the SQL query is the cardinal sin of SQL programming. Let me tell you a little story. A couple years ago, somebody put the command drop table on his license plate. When the toll camera read his license plate, it closed the SQL query to read and deleted the entire toll history. Pretty much, allowing the user to input anything directly into an SQL query is the worst code possible, which is why we include it here. Look at this diagram. If this doesn't make you weep tears of joy, I don't know what will. Let's check back with Akash and see who will claim the coveted $25 Arby's gift card.
All right, so we got our stuff coded. Let's call back Akash and see how he did. Akash?
Is this about Arby's?
No, it's about calculators, which may entail Arby's.
I'm ready.
All right. You don't gotta look so serious. Let's go over your code first. You just present it to the council here, which is me and you. And
Okay, yeah.
just pull it up.
This is bad calculator.
This is bad calculator. I see bad calc.java.
This is all my code, you know.
Wait. Is that 60 lines?
Yeah. Yeah. That's actually 80. It's 80 if you count the empty one.
You know what? I don't even know how long mine is, and you'll see why that is in just a second. So
the genius in this calculator is that he's not a very bright guy. Okay?
okay.
So he kind of makes attempts at what your answer is before he can really find it.
Oh, so AI.
Just give me, yeah, it really is. It really is like an AI agent, right?
Right,
And this
so
is what they use at great companies. Okay.
Right.
So just give me a number.
3.
Okay, 3. Yeah. Okay, so watch as my code, my AI agent takes in the input. Watch. There you go. Right. That's to use a scanner, right? Yeah. So,
Good stuff, man. Good stuff.
Right, and then the AI agent requests an operator. What operator do you like?
I like division, man. I don't know
Division?
about that. Wait. Oh, you even have a little check there. That's sweet.
Oh yeah. Oh, this is a very extensive AI agent.
Very
I'll have you know.
extensive. Question is too hard. I'm not gonna look at that one yet.
Don't spoil
Yeah, don't
the AI
spoil it.
agent.
Don't spoil it.
So 3 over 2. That's yeah. Well, okay. So see, you know, AI. We're at a point in the AI race where it can't do everything yet, right? So you might want to try something a little easier. Just a little easier. We'll run the code again. There's no loop, you know. I don't want to overwork them. Okay, so enter first number. So I'll pick another number, but maybe one easier this time.
What is okay? I don't know what's easier than 1.
3. Okay, see, now we're in the kind of the bounds of where like, you know, this agent thrives.
Okay.
So just watch closely real quick. You might miss it. So currently he's like, you know, this is how AI works. You know, it makes attempts before it can really know what it's looking for.
Yeah.
Right. So yeah. So he's kind of he's still searching. But the genius of this is once he's already guessed a number, he won't guess it again. And that's kind of part of the genius here. So it's taken him a little bit longer than, you know, usual. But this wasn't exactly the easiest question. Okay, so wait. Okay, there it is. Yeah. Okay.
That's perfect, and that's the number we needed.
Right. Right. And it's like, could you have even done that faster? You know.
Yeah, bro.
That's what he made. This would be ridiculous, right? Well, why would anybody even
how would
notice?
you be able to do that? Oh, okay.
And he knows equation 4, try something easier. So he knows, you know, when things are just ridiculous. There's no like you're wasting his time, really.
This is the dumbest challenge. This is like the dumbest.
I think there's actually genius hidden here. I really do like Arby's.
All right. Yep, I can tell. So there is a slight problem with mine. Let's just say, how do I put this? It only runs on one device.
What are you running it from a server?
All right, bro. Yeah.
Was that too long?
Restart, bro. Restart. I'm keeping that in too. I'm keeping that in. I can only run it on my laptop.
Why?
Okay, yeah, we're just gonna cut back.
Alright, so as you can see, we're now on my laptop because I need to run this. It only runs on one machine. That's kind of like a downside of the code. There are a lot of downsides. And as you can see, my calculator is only 17 lines. But I'm not screen sharing.
Only 7.
My bad. My calculator is only 17 lines.
That doesn't feel like enough lines.
You'd be right, because all of my lines are in this text file, but also in an SQL server.
Why? Oh.
So if we open up this terminal here, right, we connect to my PSQL server, We're now in my PSQL server, and if I do /dt, I think it is, you can see that there's 2 tables. Huh, peculiar, am I right?
Yeah.
So if we just select from table 1, you're going to love this. So all of my code is stored inside the SQL tables. And so if you look at here, if you look at my main program here, all I'm doing is making a connection to the SQL table and then running the code that's in that SQL table. So you see fetch all, and then it execs the code. But this gets even worse, because if we go down here, you can see that it fetches again. So this is fetching it again, and then it executes the next chunk of code from inside of the first chunk of code. And so everything, and if we keep going, look at this. We got 2. This is the operator selection. And so it just keeps going. So there's 4 different SQL connections being made. And then it gets even worse. Because when you do that, what did I just do?
Oh my god.
I think I just crashed my OS. Okay. And so that's bad already, right? But there's another problem that comes with that, is that everything's, when you're running it from that exec command, you can't store like local variables that pass between the exec commands, because for some reason Python didn't think of that. Come on.
Wow, yeah. What?
If you can hear my fans running right now too, that's because this is a pretty labor intensive code. So what we did is, here at Flingbor Investment Fund, we created a second table for the output. So that'll store all our variables. So all of our variables are also stored in another table. And every time you want to use the calculator, you also have to truncate output, which means just delete the whole table.
Oh my god.
So let's just run this really quick. Let's see how this works. So we do have to quit, because if you're running a current thing, it won't work. And so let's just clear that, and we'll just run my Python here. And so don't worry about that. That's just a print statement. So let's just input some numbers here.
10.
10. Now watch this. This is my favorite part. We can do like 10 times, so 3. And look, it works. It's 30. Don't mind that. So it's 30.
Oh
but now if we run it again and you don't go and truncate the table, it's still 30, because it's still reading the first 3 values from the output table. And I could fix that pretty easily, but I just didn't feel like it. So now I want to show you something funny here. And I'm no computer nerd, but this might not be good. So if we open up our system monitor here and we just watch this, let's just watch the CPU here. It's obviously running kind of high.
Yeah.
I don't know if this is going to actually show because it's fluctuating so much. But if we run, you saw that spike, right?
Yeah.
So it's kind of fluctating, but we'll see if we can see anything. It literally it jumped up 3%, bro. I'm not crazy.
Bro.
Look at that. It jumped up to 10% there. But yeah, that's my code.
Oh my god. How did you fix errors? How did you actually, can you even tell?
So with the debugging, it's kind of like guesswork, because everything just points back to the original statement. So if there's an error somewhere, you just kind of, okay, well, because debugging's for nerds, right? If you don't code perfectly, yeah. So that's the competition, people. If you want to vote for me, vote Flingbor in the comments. If you want Akash, put Akash's name. I'll read them, and I'll give out the Arby's gift card accordingly that I still have not bought. So eventually he'll get one. Maybe I will. All right, back to you, Flingbor. Okay, bro, we're done. Beautiful. We both created utter pieces of trash. Terrible code that should never and will never be used. What a good use of our short time here on Earth. If you want to support more Arby's gift cards, drop a like and subscribe. Every subscription we get is one more line of code that nobody can read. Make sure to join me next time, where I reinvent the wheel to turn unstructured data into useful business insights.